Okay, I think we are officially ready to start. It is my great pleasure to introduce our next AMA guest, Işıl Dillig. Işıl is an associate professor of computer science at the University of Texas at Austin. She leads the Utopia Research Group there, and they do fantastic work in program analysis, program verification, and program synthesis. She is the recipient of a Sloan Fellowship and the NSF Career Award. She's a long-standing member of the PLDI community and has several PLDI distinguished papers. So we are very fortunate to have her here today. So welcome, Işıl.
Thank you, Emina. It's great to be here.
We will start by asking all the questions that we have in Slack here, and I will go roughly in order. If there are questions that seem a bit longer, I might save them for the end. So the first question is from John Wickerson from Imperial College London, and John is asking, what would you be if you were not a computer scientist?
Oh, okay. That depends whether you're asking me about the universe in which I have to make money for a living or not, but
let's say you didn't.
If I didn't, one thing I would be really excited to do would probably be, like a nature photographer, because my two, greatest passions, I'm really interested in photography, and I also really like outdoors and nature. So, being like working for something like the National Geographic would, allow me to pursue those two hobbies at the same time.
And for those of you who don't know, I actually asked Işıl this before the stream started. The wonderful background that she has is one of the photos that she took. So Işıl would be a nature photographer if she didn't have to make money for a living. What if you did, though? So suppose the same question, but you did have to make money for a living.
So to be honest, I actually really love my job. I really like being in academia. I really like all aspects of it. So probably if I wasn't a computer scientist, I'd probably still enjoy being an academic in a related discipline, probably most likely math. That's the more boring answer.
Okay. I like both of those answers. So very good. Okay, we are going to move on to the next question. And the next question is from Haipeng Kai, the Washington State University. And he says, you have been incredibly productive while producing only the best quality work. Could you share your wisdom/secret sauce behind such a success, including advice on how to advise grad students?
Oh, okay. Thank you very much, first of all, for those kind words. I really appreciate it. The secret sauce. I guess the short answer is, great students and great collaborators. But, as you also mentioned in your question, I think the most important part of being a successful academic is really being an effective advisor and a good mentor. And I think there are, three things that I try to do for being a good advisor. So one thing that's, one thing is, rather than just pushing my own research agenda on my students, I typically sit down with them to define the research problems that we work on together. So, and I think that's really important for two reasons. First is that, if they feel like I'm assigning them a problem, they're not going to be as excited to work on it. Whereas if we're, together defining the problem, they're going to be much more excited to work on it, and they're going to be much more productive. And the other reason I feel like is that if it's, every student comes with their own perspective and their own background. So, getting fresh ideas from them is really good for, constantly getting fresh ideas rather than doing the same thing. So I think there's also that aspect of it. And let's see. Another thing that I think is important for being a good advisor is kind of having the right balance between, being too hands-off and being hands-on. So basically finding the right balance between giving your students enough freedom to do what they want to do, but at the same time being there for them when they actually need help. And I think that's something that's somewhat tricky to adjust. And, this is, I think that, where you need to get feedback from your students. So you need to for instance, sometimes I'll start by, giving them a lot of freedom, but if I feel like things are going very slowly or, things aren't going as smoothly as I expected, then I tend to step in and be more hands-on. But at the same time, I say, let me know if, you know, this is not working for you, so I can adjust my advising style based on your needs. So there's that. And there's one last thing I want to mention that's been quite important and rewarding for me. Is one thing I try to do in my research group is basically create a fun, you know, group atmosphere and kind of a team spirit. And I think that's important because, you know, doing a PhD can be somewhat of an, you know, like isolating, lonely experience, and it's also very challenging. So I think it's really important to have this kind of environment where, you know, there is a support network, you know, like people are, you know, collaborating with each other and, you know, like, you know, exchanging ideas and also, you know, basically having fun together. And to facilitate that, I try to do, you know, things that, you know, like outside of the lab, we have, you know, group potlucks in my house, or, you know, we go out for drinks. So I think all those kinds of things are really important.
Are you taking old PhD student? Can I be one?
Okay. I hear you're going on sabbatical, so if you want to come visit us, you're welcome to do so anytime.
That sounds fantastic, actually. You know, once the situation gets a little bit better, I might take you up on that one. Our next question is from Fengmin Zhu from Tsinghua University. And he says, program synthesis is an old topic that became hot in the last decade. So we had novel techniques, in particular programming by examples, have been proposed to rescue end users from repetitive jobs. What suggestions do you have on doing research in this area for the next 10 years? What kind of breakthroughs or milestones are expected to be made? And will program synthesis techniques really revolutionize the software development process of business companies? So quite a few questions in there.
Yeah, that was a lot of questions. What was the first one? Can you remind me?
The first one was, what suggestions do you have on doing research in this area for the next 10 years?
Okay. I think there are three things that I think are quite important. So one of them is, and this is where something that we're already seeing, and this is the convergence between probabilistic reasoning / machine learning and you know, techniques from the PL community. And one thing that we are really good at is, you know, like we're really good at pruning the search space, and synthesis is a really, you know, like huge, you know, search problem, obviously, right? And we can basically, given some sort of partial program, we can bring all of our tools, program analysis, SMT solvers, logical reasoning, and we have very effective techniques at pruning the search space. But on the other hand, if that's not the, you know, that's one tool, but another thing that you really need is how you prioritize the search, right? You need to be able to effectively explore the search space. And I think that's where machine learning can really help. And I think basically, and we're definitely starting to see kind of the convergence of these two techniques, but I'd be excited to see kind of like more synergistic approaches that effectively couple program analysis with probabilistic techniques. So that's one thing. Another thing related to program synthesis is actually related to a paper that my student Jocelyn presented yesterday. So far, a lot of our work in the PL community has focused on a single modality of specification. We like logic, we like, you know, hard constraints, we like logical specifications, including input-output examples. So that's a lot of, you know, what we've focused on. But, you know, if you look at, you know, for instance, if you take a CS 101 programming assignment, you know, that's part of it. You see test cases, you see, you know, you see maybe some, you know, it might say your program should have this invariant, but that's only one aspect of it. There are also, you know, like people also communicate with each other, obviously using natural language, which is much more fuzzy and which we typically as PL people don't like so much. But I think if we really want to make synthesis scale, I really think it's important to explore, you know, how to combine these different modalities of specifications. I think that's another challenge that we should think about. Yeah, and yeah, go ahead. And I wanted to mention one last thing. And that's currently a lot of the work on program synthesis is kind of like one shot, right? The programmer provides one specification and, like we, turn around and give one program. And I think this works in some settings, but if you really want to make program synthesis part of software development in everyday life, I think in the near future, it's not going to be like we're going to put programmers out of their job. I think it's really important for program synthesis to be more of a conversation between programmers and automated tools. And that interaction between the human and program synthesizers is something that we need to make more progress on and think seriously about, in my opinion.
Okay, that's great. So I think that basically answers the next question that Fengmin asked, which was, what kind of breakthroughs or milestones do you are expected to be made? So I think what you're saying is we really need to work more on that interaction loop and more on those modalities. And really, those are the breakthroughs that would make, hopefully, would make it possible for synthesis to be more widely accepted by and useful to developers. Okay, so we have our next question is from Ron Garcia, University of British Columbia. And he has two questions. So the first question is, so let me ask the first question first, and then when you answer that, I will ask the second one. What is one of your favorite research papers by someone else and why? It's a good question.
Ooh, that's a tough one.
I know, it puts you on the spot, didn't it?
Yeah. Hi, Ron, by the way, a great interview. I really enjoyed that. Yeah, so I think what's one of my favorite papers? Well, there are a lot of papers, but I think I'll go to one of the, oldies but goodies. So something that really influenced me back when I was an undergraduate, actually. And this is this, probably the BLAST work from, like a while ago by Ranjit and Ken and Tom and Rupak. So that paper was really influential for me. And this idea of doing counterexample guided abstraction refinement and using interpolants, Craig interpolation to automatically refine the abstraction, that's had a lot of influence on me. And another thing that I find very cool about it is that it gives you a way of doing, verification and refutation at the same time. And I think that's really cool.
Yeah, I really like that paper too.
Yeah.
Question number 2, what is one of your favorite research papers by yourself? And what is the story behind that paper?
Okay. I don't know. I don't want to answer about the my favorite papers, but I'll mention a paper that has kind of a funny story behind it. And so when I was a second-year PhD student, so I was advised at Stanford by Alex Aiken, and during my second-year PhD, second year in the PhD program, Alex decided to go on a tour of the world. So basically, and he would come back and check in on us every, 3 to 4 months, but I was pretty much on my own. And I probably ended up working on something that I would have never worked on if Alex was there. So at the time, I was working on stuff related to program analysis and verification. But my analysis tool was generating all these integer constraints that existing SMT solvers, weren't very effective at. And I guess, I don't know, why I thought I could do it, but suddenly, I was like, oh, okay, maybe I can solve this problem. So I started working suddenly on integer linear programming, and, I went through a lot of obstacles, but eventually something good came out of it. So this is this CAV 2009 paper called Cuts from Proofs, which is, which proposes back then a new technique for doing integer linear programming. So I wouldn't say that's my favorite paper, but I think that's a paper that has a funny story behind it.
Yeah, I like the story. Good things happen when advisors go on sabbatical. I think that's what I tell my students.
Okay.
That's a good story. I like that one. Our next question is from Ali Donaldson, our general chair from Imperial College and Google. And he says, I wondered what promise you think machine learning has for invariant generation. To me, finding loop invariants, a bit like proving mathematical theorems, seems to require human ingenuity, creativity, and eureka moments. Invariant search also seems inherently discontinuous, so perhaps a really interesting challenge problem for ML.
Yeah, definitely. I mean, there has already been a lot of progress on, using machine learning for invariant generation. In fact, during this PLDI, Anders Miltner gave a really nice talk about this, how like how you can generate invariants from positive and negative examples. I personally haven't worked on this, and but I've worked on something related, which is, so we have a recent paper that shows how you can use reinforcement learning for doing relational verification. And in that context, that's a bit of an easier problem, because in relational verification, the way it typically works is you reduce it to, safety verification, to proving, standard Hoare triples. But there are, a whole bunch of ways, you can do that, right? And in that context, we were able to successfully use reinforcement learning to automate relational verification. But as Ellie is also saying, I think that was of an easier application domain, because, at every point you basically need to pick, like between n different proof rules or n different product program construction strategies. So I think, in my opinion, invariant generation using machine learning is more challenging, and I think it could be a good challenge problem.
Sounds good.
And in fact, given all this, work that's happening at the intersection of PL and ML, I think it's a really great idea to have more workshops that bring the two fields together. So at this PLDI, there was this Maple workshop, and there's also going to be a NeurIPS workshop that brings PL and ML people together. But, discussing problems like this during such workshops, I think would be great.
Our next question is from Fred Klostad from Stanford, and he asks, what do you think are the most important ways that PL research can impact the rest of CS over the next 25 years?
Oh, 25 years is a very long time. I'm not sure if I can speak for the next 25 years. I don't know. Like, obviously, I'm a big believer in synthesis. I've been, working on that. I've invested a lot of my effort in. But I think, program synthesis is a really, I think that's going to have a real impact on computer science. And I really think that's going to change the way people develop software in industry. So that's one thing. Another thing is, again, we're starting to see some research, but, as we all know, AI is getting really big, and, machine learning components are creeping up on all kinds of safety critical application domains. So I think another important way in which PL and formal methods can have impact in CS is basically bringing our techniques for, safe machine learning, basically coming together with ML researchers to be able to do things like, how do you train a machine learning model to be safe? I think those are really important questions where we can help.
Okay, we have more questions coming in. The next question is from Julia Belyakova, Northeastern University. And she says, following up on the discussion about funny stories, what is the most surprising research result you have had?
Surprising in what sense? I guess, probably I have to go back to the same paper that I was talking about funny stories, because, I was a second-year PhD student who didn't know much about integer linear programming. So it's a bit surprising that something good managed to come out of that.
But I think that's fair.
Yeah.
Okay, our next question is from Sangeeta Chaudhuri from Rutgers University. And the question is, how do you manage your personal and professional life? What kind of choices or sacrifices have you made in your life to be successful in research and academia? Do you regret any of these choices?
Okay. So I'm not sure if I'm the best person to ask this question, because, I don't have kids at the moment. So, I don't have a lot of family obligations. So if I did, then that would be a whole different story. So, and I don't know. So I guess my personality is kind of I'm a work hard, play hard kind of person. So what I like to do is there'll be stretches of time where I work a lot and don't take a lot of breaks. And then at some point I feel burnt out, like I'm not being productive. And then at that point, I'm like, okay, let me go, on a road trip, or, let me go hiking. Let me, that's kind of like I work in bursts. And, when I'm away from work, I really try to minimize my contact with work related things. And that really gives me energy and helps me be productive.
Yeah, I think that's a great strategy. It's a very good answer. We have our next question from Michelle Strout, University of Arizona. What is your favorite class to teach?
Okay. So I've been mainly teaching two classes. So that I teach at the undergraduate level a discrete math class, and at the graduate level I teach a class related to program verification and constraint solving. And I like both of them, but I really love teaching discrete math. And the reason for that is, first of all, I really like the topic. So it was, going back to my own story a bit, when I was in high school, I had no programming background. So I wasn't one of those, when I started college, I had no idea that I would end up majoring in computer science. So I was taking random classes. And at some point when I was a sophomore, I ended up taking, CS classes on programming, and I took discrete math. And that was really a kind of a turning point in my life, because back then, I used to think of CS as just being like programming. And, after taking the programming class, I liked it. But for the discrete math class, seeing that there was also more mathematical, theoretical component to CS, that was, important for me, and, gave me confidence that I'm making the right choice and going into computer science. So I really love teaching that discrete math class. And one thing I really love about it is, I get to work with freshmen. So, people who are fresh out of high school, who are just getting, used to college. And that's something that gives me a lot of energy to interact with people at that stage in their lives.
Yeah, I totally agree. I think Ishla and I have this running joke where we both teach the same courses at our respective universities. So I also teach this discrete math course at the undergrad level and the verification synthesis course at the grad level. And I think Ishla just summarized it perfectly. It is really fantastic to teach both of those courses, and for the same reasons. Yeah.
And in the fall, I'm going to have to do that probably remotely. So, Emina, I'm looking forward to your feedback about how to run that class effectively online.
Yeah, happy to chat. I mean, actually, one really good thing about this course is that it translates better online than one would expect. So it worked really well. We're happy with how things went, and I'd be happy to chat
That's
afterwards.
encouraging to hear. I'm a little bit worried about this.
I think you'll do great. I don't think there's any reason to worry. You translate very well on camera. So we are out of time and out of questions. So I think we can end this AMA session. Thank you, Ishıl, for joining us. It has been an absolute pleasure as always.
Thank you, Emina.
And I will direct the rest of you to the PLDI research papers track.